So for our new video for today, we're going to talk about the modern CPU architecture. I'm Mark Anthony Garcia, a third-year electrical engineering student of Iloilo Science and Technology University. So what is CPU? CPU stands for Central Processing Unit. The CPU is the primary component of a computer that processes instructions. It runs the operating system and applications, constantly receiving input from the user or active software programs. It processes the data and produces output, which may be stored by an application or displayed on the screen. Now, let's proceed to Moore's Law. Moore's Law refers to Gordon Moore's perception that we can expect the speed and capability of our components to increase every couple of years, and we will pay less for them. And here's the thing. Do you know that Gordon Moore, together with Robert Noyce, co-founded Intel Corporation in 1968? Pretty cool, right? The next topic is CPU architecture history. ENIAC, in full, Electronic Numerical Integrator and Computer. The first programmable general-purpose electronic digital computer built during World War II by United States. American physicist John Mauchly, American engineer J. Presper Eckert Jr., and their colleagues at the Moore School of Electrical Engineering at the University of Pennsylvania led a government-funded project to build an all-electronic computer. ENIAC was so complex that it was actually built with over more than 17,000 vacuum tubes. Just imagine that. Next is the von Neumann Architecture. Von Neumann Architecture was first published by John von Neumann in 1945. John von Neumann popularized a new kind of architecture which consists of the main memory, a central processing unit, and a set of input or output interfaces. It also introduced the four-step instruction cycle. In 1971, the Intel Corporation unveiled the Intel 4004, a single-chip microprocessor for the calculator market. With over 2,300 transistors and clock speed of 740 kHz, it packed all the computational power of ENIAC into one tiny device. Then came the Intel 8086, with its x86 instruction set architecture. It became the foundation for the modern CPU designs that we still use today. The next topic is the computing abstraction layers, which has two subtopics, the binary system and the computer abstraction layers. Computers use binary system, the digits 0 and 1 to store data. The circuit in a computer's processor are made of billions of transistors. A transistor is a tiny switch that is activated by the electronic signals it receives. The digits 1 and 0 used in binary reflect the on and off states of a transistor. Computer abstraction layers allows us to build complex computing structures from the bottom up that would be impossible to visualize from the top down. At the foundation of the abstraction layers, we have atoms that, if put together, can make materials like silicon. Then two transistors, logic gates, functional units, execution units, microarchitecture, ISA, OS, and programming language, and then two applications on your computer. The ISA describes the memory model, supported data types, registers, and behaviors of machine code, the sequences of zeros and ones that the CPU must execute. The ISA is the dictionary of instructions, data types, and the formats that the CPU adhering to that ISA must execute. Some known ISAs are the x86, ARM, and MIPS. A microarchitecture is an implementation or specific design of an instruction set architecture or ISA. The next topic is the CPU pipeline. The first step is to fetch or retrieve the instructions from memory. Then, the CPU decodes the fetched instructions. After that, the CPU executes the decoded instructions, and then finally, the CPU stores those results. The fetch and decode stages are called the front end, while the execute and write back stages are called the back end. Now, let's talk about the speculation in CPU. First is the branch prediction. Branch prediction is used in CPU design that attempts to guess the outcome of a conditional operation and prepare for the most likely result. On the other hand, the speculative execution is a technique when a microprocessor executes a newer instructions to a branch without knowing if the branch is taken or not. Now, let's talk about scalar and superscalar execution. A scalar execution acts on one piece of data at a time, while the superscalar execution issues several instructions at a time, each of which operates on one piece of data. Let's proceed and discuss the in-order and out-of-order execution. In the in-order execution, the micro-ops are executed in program order. However, the out-of-order execution is faster with no unnecessary wait time and gives a much better performance overall. And that's pretty much it. Thank you.